Okay guys, so at some point I guess when I switched over to do these drawings because it was in another application, it kind of cut off from the video. So really quickly I just want to go over what I drew on this shared screen. So there were three concepts that were illustrated on this blank, I guess, template. It was the site of impulse, so we'll just talk about that really quickly, of multipolar versus pseudo-unipolar. So we know that multipolar are going to be my motor neurons, right, with the cell body in the CNS, and then my axon just going to go into the PNS. So right here at the axon hillock is going to be where my signal originates. So this is important because as opposed to a sensory neuron, my impulse is going to be initiated in the peripheral nervous system all the way down here. So just be aware that your signal is traveling this way in sensory and that your signal is traveling this way in motor. So a simple concept that they could try to make a little complicated in the wording by where the signal is initiated, with multipolar motor neurons being at the axon hillock and pseudo-unipolar or bipolar being far more in the periphery. The next concept is the different degenerations, Wallerian versus anterograde versus retrograde. So like I kind of said verbally, so I guess like if you had listened to it verbally and now I could draw it out, like let's just say this soma was lesioned. So eventually what's going to happen is this nerve, just this nerve, is going to degenerate. And when it's localized to just this nerve, it's going to be Wallerian degeneration. So Wallerian degeneration literally means just this nerve is what is affected. Eventually, the nerve ahead of it will degenerate as well. So that would be our postsynaptic nerve. And when that happens, we call that anterograde. So some people like to, or sometimes people get confused because even though it's the soma progressing to the axon, that's not anterograde, that's still Wallerian because it was localized to the original cell, right? And anterograde is going to be when we proceed to the postsynaptic cell and the cells thereon. So this was Wallerian, this was anterograde, and this right here is going to be retrograde, which makes a lot of sense, right? So that's the presynaptic cell that will eventually degenerate as well. Yes, so the last concept that was illustrated was our Lasar's tract. And like I kind of mentioned, Lasar's tract is for pain, and I demonstrated this by a syringomyelia. So we have a syringomyelia, right? It destroys the middle part of our spinal cord, right? Normally found in our cervical spine, and there was a little MRI that was included in the kind of handout study guide there. So let's just say this is a syringomyelia, and we're going from C2, and of course in my other example I had started with C1 and I had to use an imaginary spinal subsection. So let's try and fix that by starting at C2. So what I want to demonstrate here is kind of my rule of 5, and essentially what this means is a syringomyelia must have lesioned at least through 5 different spinal subsegments to reach any impact. So when it hits 5, I can already know without like really going into the question that only C4 is going to lose bilateral pain. And I highly suggest drawing it out every time, which I mentioned, but let's go through why C4 is the only one. So let's start with C2. So Lasar's tract has our rule of 2, right? We can go 2 up and 2 down to escape whatever is kind of in our pathway. So with C2, I can come in, of course it's sensory fiber, so I'm going to go through the dorsal side, and then normally I would synapse right there, right, and then cross over, but I can't, right? So I could try going downwards 2, and I still can't cross over at each of those, but I can go up right to C1, have a little synapse, cross over to my ALS up there, and go right up. And the same goes for the other side. So now let's talk about for C3. So C3 can come down, it's going to come in, can't cross here, that doesn't work. Ascend, can't cross there, but we have our backup, we can go up 2, can't cross there, and ascend. Alright, so let's talk about for C5, so we'll skip C4. So C5, we come in, and if we ascend 2, we still can't cross over, right? So that's going to be a problem, but what we can't do, that's really, really helpful, is we can descend, right? So we can go down 1, and nothing's going to happen there, right? Because we can't cross over, but we can go down another 1, right? So let's draw another little guy right down here, and we can go over, and we can cross over here, because this is fine, and my ALS track is totally fine on all my sides, right? So then I can ascend and go do my thing, make it up to the brainstem, and be able to feel that pain and temperature change. So yeah, so we descend, and then we can ascend right afterwards, because my ALS track is not affected, right? It's just the middle part of my spinal cord, which means it's the crossing. So another thing to keep in mind is at the level of the crossing is where we synapse, right? So this is all going to be my same nerve descending, and then right down here we just have that synapse and cross over and ascend. So let's talk about C4. So C4 has very limited options, and by limited I mean no options. So we come in from the side, right? And I can't cross over here, right? So that doesn't work. I ascend, can't cross over. I ascend, another one, can't cross over. Okay, so none of that worked. Descend, can't cross. Descend, can't cross. So boom, out of luck. So, but my only one that was affected was C4, right? So even though the sternum hylia went through 5 different cervical spinal segments, and most of the time these will be found in the cervical spine, the only area that was affected is C4. So I hope that clears things up, and that would be bilateral pain and temperature lost, of course, on both sides, with just one area being affected. So yeah, hope that this was able to kind of accompany the document, the Word document. So thank you.